Hello, this is Anya Maunik Lakshmi. My project topic is micro oven functionality and design insights. Agenda: explore operation modes and specifications. Analyze tools for microwave functionality. Discuss embedded systems in microwave design. Examine coding keywords and data types. Illustrate microcontroller and design selection. Understand block diagrams and system layout. Introduction of microwave ovens. Culinary efficiency. Microwave ovens can reduce cooking time by up to 70%, significantly enhancing kitchen productivity in commercial settings. Nutrient preservation. Cooking with microwaves can preserve up to 90% of nutrients in vegetables compared to traditional boiling methods. Energy consumption. Microwave ovens typically use 50% less energy than conventional ovens, making them a cost effective option for households. User safety. Modern microwave ovens incorporate child safety locks and automatic shut off features to prevent accidental burns and fires. Importance of microwave technology. Energy efficiency. Microwave ovens consume 50% less energy than conventional ovens. Speed of cooking. Microwaves can heat food in a fraction of the time compared to conventional methods. Nutrient retention. Rapid cooking preserves more vitamins and minerals in food. Versatile applications. Used in deforesting, reheating, and cooking diverse food types. Smart features. Integrations. Integrations with lot Integrations with lot allows remote control and meal planning. Cost effectiveness. Shorter cooking times lead to lower utility bills, saving money. Migration modes. Mode 1. Setting the timer and cooking time accurately is crucial. Mode 2. Understanding power levels can optimize cooking results significantly. Mode 3. Using deforest mode ensures even thawing without cooking food. Mode 4. Grill mode provides growing and crispiness to certain foods. Mode 5. Combination mode merges microwave and grill for better efficiency. Mode 6. Quick start allows immediate cooking at full power, improving flexibility. Mode 7. Sensor cooking adjusts time and power autonomously based on moisture. Key tools and components overview. Type, purpose, specification, impact. Sensors, type, temperature, purpose, minor, monitor, heating, specification, thermocouple, impact, optimizes cooking. Microcontrollers, type, PIC1C6F877A, purpose, control operations, specification, 8-bit MCU, impact, increases efficiency, power supply, type, AC input, purpose, for power device, specification, microwave transformer, impact, ensures safety, control interface, type, touchpad, purpose, user interaction, specification, resistive, impact, enhance user experiences. Core findings. Integration advantage. Streamlined components enable increased functionality and efficiency. User experience. Intuitive controls lead to better customer satisfaction rates. Safety compliance. Adherence to standards reduces consumer risk and liability. Embedded system in microwave ovens. Problem faced. Control accuracy and user interface challenges exist. Solution offered. Integrate real-time microcontroller capabilities effectively. Benefits. Enhanced cooking precision improves food quality. Approach. Access. Evaluate current embedded system functionalities and limitations. Design. Create a schematic incorporating best microcontroller practices. Test. Conduct rigorous testing for operational reliability and safety. Deploy. Implement in production for consumer microwave models. Understanding keywords and data types. Features. Efficiency. Keywords facilitates the handling of code complexity effectively. Compatibility. Data types ensure proper data handling across the system. Readability. Keywords enhance code readability, making debugging easier. Optimization. Proper data types can improve memory usage significantly. Overview. System design enhances overall effectiveness in system development. Code quality improves maintainability of the code over time. Performance leads to faster execution and reduced lag. Debugging eases the tracing of errors during development. Operations in microwave functions. Flowchart. Start cycle. Food warmed. No. Left. Continue heating. End cycle. And this is a sample flowchart for this slide. Please rearrange the flowchart to convey a message. Utilizing conditional statements. Input check. Conditional evaluation, mode selection, temperature adjustment, start cooking, monitoring progress, completion alert. Input check. Verify your microcontroller role in operation. This is a sample graph with some sample data. Replace it with your own graph with your relevant message. Here it is a graph. Core findings. Error reduction, 20% decreases in operational errors, rates observed, energy efficiency, MCU improves, energy used by at least 15%, improved control, 30% more precise control during cooking cycles. Selecting the right microcontroller. Microcontroller selection factors. Cost, performance, power efficiency, compatibility. Cost. Enhance features with budget to avoid overspending. Performance. Ensure adequate processing power for microwave functions. Power efficiency. Select a microcontroller that minimizes energy consumption. Compatibility. Check integration with other microwave components. Introduction of PIC16F877A microcontroller. Cooking control. The PIC16F877A microcontroller enables precise temperature control and timing functions in microwave ovens, ensuring accurate cooking performance and minimizing energy waste during operation. User interface. The microcontroller facilities intuitive user interface design, integrating buttons and display modules to enhance user experience while minimizing errors rates in setting cooking parameters. Safety features. Incorporating the PIC16F877A ensures critical safety measures such as sensor integration for door detection, preventing operation unless securely closed, thereby reducing risk of accidents. Block diagram of microwave oven. Here it is diagram. Power unit supplies energy requires for microwave operation. Control system regulates cooking duration and power levels. Cavity magnetron generates microwave radiation for heating food. Turntable mechanism ensures even cooking by rotating food. Flow. User sets time and power settings. Microwave being heating process. Waves penetrate food and generate heat. Signals end of cooking cycle to user. Integration of sensors and actuators. Sensor. Gather environmental data for processing and control. Processing analyze sensor data to determine operational needs efficiency. Decision evaluate conditions and decide to actuate responses accordingly. Actuation. Execute physical changes using actuators for system response. Feedback. Obtain feedback on actuator performance for adjustment. Optimizing. Refine processes based on feedback to to enhance efficiency. Power of management in microwave ovens. Strengths, weakness, opportunities, threats. Strengths. Advanced power management. Thermal control mechanism explained. Here it is flowchart. Start heat cycle. Active. Maintain. Reduce. Cool down. Sustain. End. This is a sample flowchart for this slide. Please rearrange the flowchart to convey our message. Future trends in microwave technology. Smart integration. Integrating load capability for remote operational monitoring, energy efficiency, adopting advanced energy saving technologies to reduce consumption, emerging materials utilizing innovative materials for better thermal management and safety, AI usage, applying machine learning algorithms for optimized cooking settings. Evaluating product performance metrics, energy 90%, speed 4 minutes, capacity 30 L, real, re, reliability 98%, energy efficiency rating, cost analysis of design and manufacturing, cost benefits, material sourcing for components, labor, cost for assembly lines, equipment maintenance during production, testing and quality assurance expenses, benefits, competitive pricing for consumers, enhanced production efficiency gains, reduced waste through optimized design, long-term ROI from efficient systems. Sustainability in microwave design, energy efficiency, implement components that minimize energy consumption during operation, material selection, choose recyclable materials to reduce environmental impact in manufacturing, heat recovery, incorporate systems that utilize waste heat for other processes, life cycle analysis, conduct assessments to identify sustainability gaps throughout product lifespan. Thank you for giving me this opportunity. Now here, my friend Jaikumar will continue.
This is the Ampilam XDA interface. We're opening the file. We're setting the settings. So we are setting the parameters and going into the I'm going to open the file. This is our file. This is the main file in which we have written the code for everything. This is the CLCD file. This is push button file. In this we have written the delay and everything. Operations. How to implement it. In which we have upgraded the timer, everything. This is the PIC In this we have setting a PIC Genius board, setting the microcontroller, PIC 16. This is the help toolboxes. And we need to dump the file. So we are going to file and uploading the file, micro oven. While we're saving, see it was powered off. In this we have different features, micro drill, which we program itself. The timer has started. We're selecting the push buttons and entering with the start. Sorry, and if you want to start or resume, we press the 4. For pausing, 5. See, the time was up. Again, we are doing that, the same. See, again, we have timer set. The fan is rotating. After completing the time is up. The fan was turned off. We will display the message. The time is up. That's all. We are selecting the different things. That's all. See, we have set the time up to 180 seconds. See, this is the thing. The fan was rotating and it will stop at the end of the time. But the time was decreasing very slow. After turning off the fan, it will display a message. The time is up. Now we have the time up to 1 minute. So we are finishing that. Mm, So now the fan gone off after 12 seconds. I think it's completing. Yeah, it's complete. See. So we have the message. It was time up. This is the code we have implemented now in the Pig Genius code. That's all. Thank you.